Oh my God. After my computer updated yesterday, it's been shutting down like every 2 seconds. So here's hoping it doesn't happen right now. Right before leaving my office, I had everything set. Sure enough, it was off. Fortunately, it's not too bad here. Just going to open up Colab, have it good, ready to go. My God. Okay, so this is basically where we ended last time, right? Is we saw, okay, there's values. The values can have different types. We saw strings. We saw integers. We also saw floating point numbers. And we even, I mean, I did it really quickly, but you can even ask Python what the type of a specific value is. So if I say print hello, well, the value is the literal string that says hello. And remember, literal is when a value is just like literally written like that. It's very explicit, as opposed to a variable, which we'll see in a moment. But that just says hello. I can actually ask the type of it. Now, what I'm doing here is, first of all, it says str. It's class str for string. If I changed it from a string to 1, it'll say int, and if it's 1.0, it'll say float. And if it's the string 1.0, it'll say string. They're all different values. Even though they look the same, they are different, and they have different types. One thing to note here is I've actually nested a function call inside of another function. So there's actually a lot happening on one line of code here. Typically, you can write code like this. Typically, I avoid it. Typically, programmers would say avoid this. Keep your lines of code like simple. Keep them like single purpose so it's easier to understand. Because remember, and I'll say this a lot through the course, computer code is not written for computers. It's written for humans. The program that takes the code and turns it into something that can run on the computer, it turns it into something called machine language. That's for the computer. Code is for humans. So you want to make it readable. But just to warn you, there's actually a lot going on here. I'm saying, okay, you might think, where do I start actually doing everything here? Well, the print, which is the most outside, is going to be like the last thing that's done. You might remember this from like order of operations in math. You know, you do the stuff in the brackets. You can even have like nested brackets. You do that first. So all the way down, I've got the string, which is a literal 1.0. And then I'm asking it, okay, what's its type? And its type is, well, it's an str. And then I'm printing out the result of what the function type gave me, which was str. Cool? Great. Yeah. We're using two functions in the above example. One's print, one's str. So you know what here? If you've got things, your computer ready to go, here's a quick little activity for you to make sure you're awake. Write a single line program to print out the integer 1. Now write a single line program to print out the string 1. Can you tell the difference by looking at the output? Do that. I'll give you 2 minutes to try to get this one going. Okay, who here got it working? Who here will totally have it working in like 20 more seconds? All right, cool. Well, here's a solution. Here is, that's what I wanted. I printed out, clearly the first one's just the integer 1 because you're seeing just the literal 1. And the second one's a string, and we know it's a string because it's in quotes. But from the output, can you tell the difference? Can anyone tell the difference? I certainly can't. And there's a reason for that. And now I'm going to get extra technical here, and it's not really that important for you to remember this, but it's because whenever you print something, whether it's an integer or a string, Python's actually going to convert it to a string before it actually prints anything out. So at the end of the day, it actually is the string 1 that's printed out, but you can't actually tell the difference. You don't need to convert the string 1 to a string before printing it out, but the integer 1 gets converted to the string 1 and then gets printed out. It happens automatically with the print function. Now, I'm going to show you all one thing, and this is one thing I want everyone in this room to pay attention to because this can bite you in the ass real bad, and it is the #1 thing I dislike about Colab, or this style of programming, which is called notebook style. This is the #1 thing I hate about it, and it confuses new programmers all the time. Here, okay? I did that. Let's get rid of this line here real quick. Watch what happens. I say print 1, you see the 1. And now I'm not saying print 1, I'm just hitting the number 1, and I see the number 1. I can even do something like this. Print 1 plus 1. It's going to evaluate the expression first. 1 plus 1 is 2, print out the result. Or I can do 1 plus 1, and we see the result. So this now leads you to believe, oh, well, you know, whether I write print or not, it's actually printing out the result, right? That's what it looks like. It's not. That is absolutely not what's happening at all. It's tricking you into thinking that's happening. Pay attention and listen, because this will screw you up a little bit later, mixing this up. In the first one, what's happening is, okay, 1 plus 1, it evaluates that to 2, and then we explicitly say print it out so it shows it to you. The second one, what happened, this is what's going on, is it does 1 plus 1, and that evaluates to 2. But we got a bit of a problem. On that line of code, there's now just this value 2 floating around. We're not doing anything with it. What did I do with the result of 2? Nothing. The previous example, I printed it out. Here, I didn't do anything. So what's happening is Colab is saying, hey, there's this like dangling value 2. And whenever that happens, and it's only that last line of code in the cell, if there's ever a dangling anything, Python goes here. And it just shows it to you, but it doesn't print it out. It actually acts a little bit differently. You just can't tell here. I'm going to first show you that it really is only the last line. So we see here, 1 plus 1 is 2. And if I say print, 2 is not shown anymore because the last line of code didn't have a dangling value. Nothing was lost. If I add this after, 1 plus, what's going on here? We see the 2 because it is the last line of code. But it is not printing it out. Here is the easiest way to see the difference. I'm going to print out the string 1. There, you see it. And then I'm just going to do this. Oops. That last line, I just said, okay, the string 1, so there's a value there, but I didn't do anything with it, so Python showed it to me. But you can actually tell a difference here, can't you? The first one, it just printed out 1. The second one, because it's showing you the value, and that value happens to be a string, it's showing like the quotes around it. So this is like the only example that makes it really obvious that there is, in fact, a difference here. Here's the moral of the story. If what I just said to you made perfect sense, great. If what I said to you made sense, but you don't really see why this is important, whatever. If what I said to you didn't make any sense at all, fine. Here is the one thing. If you ever want to print something out, use the function print. Never, ever, 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 ever rely on just that. If you want to print something out, say print. That's it. And in spite of warning you, half of you are going to mess this up in a lab. But that's fine because that's a great place to mess it up because we can fix it. All right, cool. Variables. Now again, great. People in lab, you're whizzes at this already. So a variable. A variable is something that can hold a value. That's really it. Variables that you store values in a labeled name, and you store values into variables by using the assignment operator. Raise your hand if you are a hardcore mathematician. Raise your hand. A math major, put up your hand. Okay. A single equals does not mean equality in programming. I'm sorry, deal with it. It means assignment. It means you're assigning a value. Equality is a little different. If you want equality, you do two equals that we're going to learn about a little later. But equals on its own is not a statement of fact. It's not saying x equals y, and that means, oh, that they're equal for all values. No, no, no. It's an assignment. So on that little code thing right there, when I say a equals 5, I wrote the literal 5, and I assigned the variable a to have that value. So a is storing the value 5 now. But a is not a literal, it's a variable. Because a is just some label that is storing the value 5. M is storing the value, well, it's a string that says some string. They're both variables. In the above example, a now has the value 5. Both the variable a and the literal 5 now have the same value. Both the variable a and the literal 5 both have the same value. Probably don't need two boths there, whatever. Let's go clear all this out. So if I say a equals 5, and then I say print 5, print a, what do you expect to see as a result? If you've never seen this chunk of code before, maybe you can use your intuition to tell me what you think you're going to see when I hit run. We're going to see two 5s. Let's see if you're right. Raise your hand if you're like, yep, that's exactly what I thought. Raise your hand if it wasn't. What did you think it was going to be? You thought it was going to be like 5 and then a? The way to do that, we could do that. But if we wanted it to be like the string a, we'd have to have made it a string. Now it'll be a. But the a is the variable, because I just assigned it that. What do you think if I hit run on this? What do you think is going to happen? Let's see. Well, nothing, because it's going to say, what the hell's b? I didn't assign it any value. What do I print out? Right? Makes sense. Okay, here's the warning. Yeah. Equal has a very different meaning if you're familiar with math, and math equal. When one writes a equals 5, it means that a and 5 are equivalent as they exist. It's a statement of fact. In Python and many other programming language, it's not a statement about equality, it is an assignment. They'll be equal after the assignment, sure, great. But it means, okay, 5, I'm putting you into that variable a. You can think of the variables as little boxes with a label on it. You can come along and I'm like, okay, I'm going to put a 5 in here for now. Great. So later, if I go back to that box, I go, okay, what was in here? Oh yeah, it was a 5. It's a place to store stuff. Storing values, data, into variables and then performing operations on them is really a huge chunk of all the programming. So this is critically important to understand. Here we go. let's take this chunk of code. Before I hit run, take 15 seconds, look at those 4 lines of code, and that output is not associated with that line of code. Let me clear that output. That was it complaining when I had the B there. When I hit run, take 15 seconds, come up with an answer in your head, commit to it, I'm going to hit run, and you're going to tell me if you were right or wrong. What do you think is going to happen? You may have never seen this before, but there's a chance you will know exactly what's happening based on your intuition. There's no trick to this. There's no secret. There's no catch. It's just what we just learned and apply it. Okay, first things first. What do you expect to see printed out at the very top? Someone yell. 11. Why? Because 5 plus 6 is an 11, and then I say print it out. So we'll see 11. Great. Now let's see what happens when I hit run down here. We see 11, 11. Raise your hand if you were right. Raise your hand if you weren't right. I find it more interesting if you weren't, because then we can try to talk about why. Maybe something went wrong. So let's just talk about it real quick. So the first 11, that one's obvious, because 5 plus 6 is 11. The literal 5 plus the literal 6, well, that's 5 plus 6, that's 11, printed out, 11. Next, what do? We say, okay, A, you have the value 5, you are 5. B, you have the value 6, you're a 6. So then I say A plus B. What's A? What's B? So what's A plus B? And then what do I do with it? Print it. 11. 11, 11. Wow. You're experts already at this. Holy moly. When I made a moment ago, I said there's no trick to this. With programming, there's no catch. All of the simple little rules we use, they're the same simple little rules we're going to use. So even though I just said, like, wow, you're experts already, this is all it's going to be. Assigning values to variables, using the values assigned to variables, screwing around with it. So when I say, yeah, that's it, yeah, you're going to be doing a lot of that. Sure, it's going to seem more sophisticated as you go, but yeah. Okay, both print functions call will print out 11. The first one adds the literals 5 and 6. The second one adds the variables A and B. Now, here's a good activity. I'm going to give you a couple minutes for this one. There's 5 steps. Have at it. Assign various values of types, strings, integers, and floats to variables. Try adding variables of the same type. Try adding variables of different types. Try assigning like that. Figure out how to display the current contents of a variable. There you go. Have a go at it. Give it a try. Play around, and then we'll talk about it. Does anyone run into any issues? Pardon? Can't do number 4? One more, yeah. Probably says like can't assign value to literal or something. Yeah. Okay. Raise your hand if you're done. Raise your hand if you'll be done in like 30 more seconds. No? All right. So the first one, whatever, assigning a value is a bunch of variables, okay. What happened if you added 2 integers together? What do you get? An integer. They're sums. What happens if you add 2 floats together? You get their sums. They're decimals, right? What happens if you add 2 strings together? They smush together. They concatenate. Did anyone try to add an integer and a float? You get a float, but it's still just the sum, right? What about adding a string and an int? We already saw that. It's not happy with it. Did anyone try multiplying a string by an integer? What happened?
I did 4 times 3. It just gives you 4 threes.
Nice. So you said the string 4 times 3, and it was 4, 4, 4.
Yeah.
What would happen if we did like times 10? What do you think? You probably get 10 of them, yeah. If you multiply a string by a number, it just repeats the string that many times. It's kind of neat. Did anyone try any other combinations of operators and types? So number 4, it didn't work. You get a bug. You get an error message that looks like this. Cannot assign to a literal. And it gave you a suggestion. Maybe you meant this. That was an equality check. Assignments, the thing you're assigning to must always be on the left-hand side. The right-hand side is evaluated, and then it gets thrown into whatever's in the left-hand side. So that's no good. And who figured out a way to display the contents of a variable? This is kind of a stupid question. What did you do? You just printed it out, which is great. Imagine here, you hit run, pretend a million lines of code ahead, and I hit run, and I was expecting to see like 14 printed out. Well, hold on, B is 6, and A should be 5, or sorry, what's 6? 8. It should be, but it's not working. Why am I not seeing 14? Well, let's check. I know A is literally right there, but let's forget. Print A? Oh, it's because it's 5, not 8. That's why it's 11, right? Print, this is what I meant last time when I was saying print is going to become your best friend. Because it's going to be important to keep track of what values your variables actually currently have, especially when debugging. Cool. Any questions about that? Did anyone run into any hiccups or anything? When I don't hear anything, that means I assume everyone is 110% okay with everything we've learned so far, and there's no issues. All right, fantastic. Okay, naming variables. You can name variables whatever you want, with a few exceptions, because programming languages will have reserved keywords, so you can't use a keyword as a variable name. So, for example, def is a keyword. So if I say def equals 5, and I hit run, it's not going to work. Oop. If I don't use that, it's fine. So now defo stores the value 5. Python wants variable names that begin with a letter also, and are limited to what non-alphanumeric, there's limits to what non-alphanumeric letters you can use. You can use like underscores and whatnot. Don't start a variable name with a number. It won't let you do that. It's unhappy. And a good choice of variable names. So the variables we saw so far all were like 1 letter big. That's terrible to do in practice. You don't do that. Variable names should be as descriptive as possible. Every time a new programmer does it, they think it's better to have like short variable, it's smaller, so it's better. No, there's no advantage to that other than making your code more confusing. Imagine I have a variable holding the value that's supposed to represent the density of something. A good name for that variable is density. So anyone who looks at that code and goes density equals 5, they go, oh, so the density is 5. Less good would be D. If I just saw the letter D and I didn't know the context of what your code's doing and I see D equals 5, I'm like, but what's D supposed to be? Density tells me something. D, not really. If I knew the context of what the program was doing, maybe I could conclude that D is density. But if I don't, D is just this like, what the hell is that supposed to be? Feel free to be verbose. In fact, I encourage, just have good variable names. Do yourself a favor. Do the TA a favor when it comes to marking. So there was the example about def. You can't use def. It's a reserved word that we'll learn about a little bit in a week or so. 2 important conventions. Everyone listen up. So, there are rules of the language that Python forces you to follow. And then there are rules of the language that you don't have to follow, and the code will still work, it'll run, but if you don't follow the rules, everyone hates you. You're an asshole. So here's one of the rules. All of your variables are what they call in snake case. That is a fancy way to say lowercase, all your variable names should be lowercase. Start lowercase. And if there's like multiple words, you separate them with underscores. This is counter to what people would call camel case, which is like hello world. That would be a camel case style. Some programming languages use that as a convention. Python does not. If I wanted the variable named hello world, I would do hello world like that. That would be correct. You saw Python was happy to have it not in snake case, but I won't be, nor would any other programmer who knows anything about Python. So there are some rules that if you break, Python will say, nope, can't do it, done. And there are some rules where it's like, well, you can break those rules, but you're an asshole. So don't be an asshole. Use snake case. Simple, right? Okay, like full name or first name equals James or something, right? So that's a good variable name. A bad variable name here would be like FN. Because I look at FN. What is FN? All right? Yeah, I don't know. So yeah, there we go. Snake case. Now, there's another there's another thing called constants. Constants are just variables that programmers use in a very special way. At the end of the day, it's just a variable, but it has a special meaning. Sometimes in your code, there's variables that are getting their values signed, updated, changing them a little bit, doing this, putting it back, doing all these calculations. And then there are some variables that you as the programmer set, but then you leave it alone. The code itself won't change the value of that variable. You can, as the programmer, like, before you hit run, you can change it and hit run again. But the code itself is not to modify it. So if I go back here, let me show you what I mean. If I said A equals 5, and then A equals A plus 1. So here's a tricky one. First line of code, what value does A have? 5, great. Now let's go to the second line of code. What is it saying? Well, it's saying A equals A plus 1. So if you're a mathematician, you're looking at this going like, all right, that doesn't really, because remember, it's not a quality. It is just a statement. So we evaluate the right-hand side first and then put it into the left, whatever is on the left. So we have to look at the A plus 1. What value does A currently have? So what is A plus 1? And then where do we put that 6? Back into A. What happened to the 5? It's gone. It's obliterated. I took the 5 out, threw it away, put the 6 in, I'm happy. Print out A. This is an example of the first line of code there. Clearly I set A, but when I hit run, the program itself modified what value was in A. A constant would be a variable that I set, but the code doesn't modify it, leaves it alone. And constants have an important purpose. So I look at this code right here, right? I'm writing a program where you're doing a lot of calculations with sales tax. Some bill equals 1045 times 1.15, and another bill is 499 times 1.15, right? That just calculates whatever the bill is with sales tax, right? That's all. Any questions about that? Now, in this particular example, I know what this code is supposed to be doing. You know what it's supposed to be doing because of that, you know. But let's say I'm from some state where sales tax is hilariously low, and I would look at 1.15 and I would have no idea what that. I would be like, why the hell is someone multiplying 1045 by 1.15? Are they just adding a 15% markup for some reason? Like, what's going on here? I just see the value 1.15. What does that mean? So like, we know, but someone might not know, because right now it's just a value. And what if I've got like 1 million lines of code like this in my program, and then the government decides to lower sales tax by 1%? Right? I'm going to have to go and update every single one of these to say, okay, 1.14. Right? Not too bad. I, find and replace. Fine. So what we do is we set it to a constant. I say sales tax equals 1.15, and then I use it just as I would that value. There's a couple things to note here. First and foremost, ignore that right there. Now, if I'm from who cares where, I see, some bill equals 1045 times whatever sales tax is. I now know exactly what that is. There's no question. I'm not left scratching my head. No one needs to scratch their head figuring out what's 1.15 supposed to be. Now it's just some value times sales tax. Oh yeah, okay, that makes sense, right? There's no guessing, no guesswork at all. You immediately know because the variable name, the name of that constant, was very descriptive and good. So this is one of the values of it, of using a constant. Another thing to note is there is a convention to follow with constants. Who can tell what the big difference is with this variable and the other variables? It's not a trick question. It is that simple. What were you going to say?
Uppercase.
It's all uppercase. Yeah, that's the rule. The convention is use all uppercase. It's still snake case, but you use all uppercase. Because then any other programmer, and this is a convention beyond just Python, this is a convention across many programming languages. I come across this and I see it and I go, oh, it's an uppercase, it's a constant, leave it alone, don't touch it. Now, in some programming languages, if you define something as a constant and your code does try to modify the value in that constant, the programming language will say, nope, not allowed, can't do it. It's a constant, you're not allowed to change it, don't. Python will let you. But don't, because then you're breaking the convention, right? So although you can change the value of a constant, you're not supposed to. You leave it alone. What I mean by that is, like I do that inside the code. Well, that's bad because now the program is actually modifying the value of sales tax. I hit run, it ran. I mean, nothing got printed out because I didn't tell anything to get printed out. But it ran and it was happy. Some programming languages, if there was a constant defined and I hit run, it would go, nope, not doing it. You said it was a constant and you're changing it. So either you did something wrong or it's not a constant. Just either way, fix it. Which is kind of nice. You might say, oh, so it's going to be picky. But it's actually kind of nice because it enforces that you followed the rule, which means you're less likely to make a mistake. Python gives you the flexibility to change it if you really want. But did you? You probably don't. You probably messed up. So Python, in spite of its flexibility, really does let you make a lot more mistakes. So just be aware of that. In other words, don't do that. You set it and you forget it. Me as the programmer, I'm allowed to change it. And I hit run, great, it's happy. But the code can't modify the value itself. All right, Yeah, okay, great. Any questions about any of that? By the way, did anyone notice, so first of all, obviously I record these lectures, right? And I took my mic off, so it might be low quality for a bit, just because it's running low on batteries. But did anyone notice that there are some other videos that I have? If you went through those, I'm going to warn you. Those are actually using a different version of Python. And that version is Python 2. We are using Python 3. Some of you even noticed that there is, in fact, a difference in the lab yesterday with Caddis, right? It asked you which Python you're using. If you watch the videos with Python 2, they're going to be immensely helpful. The differences are going to be so minimal. There's only two differences that would really come up, that would really affect you at this stage. One is in Python 2. I'm just giving you this as a warning if you watch it and you're like, why are there no parentheses around the print? In Python 2, print is not a function, it's a statement, which is a weird way of saying in Python 2, if you wanted to print something, you would say print like that. In Python 3, that won't work. You have to do this. So if you're watching those videos and you're going like, where are all the brackets for the prints? It's because it's Python 2. That's why. There's another example of where it's different that pissed every programmer off in the world, and Python should feel really bad about what they did, that I will explain another time. You know what? I can explain it real quick here. Print. What's 5 divided by 2? 2.5. Oop. Right? Yeah, nothing weird, right? Now, let me ask you, what's 5 divided by 2? I know I just asked that question. Answer. 2.5. No, it's 2. So, every other programming language, many of all the programming languages that are remarkably popular, including up to Python 2, and including Python 2. Whenever you did division of integers, the operands were integers. The operator is division. And the result of that operation needs to also be an integer. Meaning 2.5 is not a valid answer. It would, what we call, truncate. It doesn't round. The answer could be 2.99999999999, but if you're doing integer division, it goes down to 2, no matter what. It always just rounds down. It truncates. So all these other programming languages, since the beginning of time, whenever you use division, it would do integer division. And then if you wanted, and integer division is remarkably useful. There's a lot of reasons why we like it. It's not obvious right now, but it will be in a couple of months. There's a lot of value in integer division. Python 3 came along and said, nah, screw it. Let's just change it so division does floating point division automatically. So now all of the code people had in Python 2 that depended on integer division, well, they were screwed now. It broke a lot. It was really bad. I'm not saying having an easy way to do integer division isn't good. I'm saying the fact that when they transitioned to Python 3, they made the default change, and then they added a special version of division to do the division everyone would expect. Where a lot of people felt, well, no, if you wanted the easy floating point division, just make that the exception and stick with the convention everyone's been using since the beginning of programming. It doesn't really matter at all, but that would be the other difference you see in Python 2 if watching those videos. Those videos are great. They work you through some specific problems, even more exercises to practice with. Yeah. Any questions before we go to the next topic? So what do we see this topic? We saw print. We saw there's values, and the values have types. We saw integers, strings, and floats. We're going to perform some operations on them. We can print them out. And we saw variables. Variables was the big thing. There's literals, and then there's variables. That was the big stuff that we saw. Okay, statements and expressions. Programs are made up of multiple lines of code, right? As we saw here, there, right? Great. Statements, so yeah, each line of work is some sort of thing that needs to get computed. Some amount of work that needs to get done. Some number crunching, right? Some number crunching and maybe we print out a value. Some number crunching and maybe we store it for later, for more number crunching later. I don't know. Now, a statement is an instruction for Python to do something. If you type a series of statements and hit run, Python does what you asked, or at least it tries to. It might crash. Maybe you asked it to do something it can't. And some statements result in some immediate output. So, for example, print hello world, right? There you go. Others will do some work behind the scenes, like some variable is 5, right? So I didn't see any output when I said some variable equals 5. It won't show me, but something happened, right? That was another statement. All of these here are statements. This is a statement, creates the constant, a statement to do some calculation, store it, a statement to do some calculation, store it, and then a statement to print out some result. The only one of those statements that showed me anything was the last one, this 5 divided by 2. The other 3, it didn't show me anything, but it did still do the work. Expressions, on the other hand, are all statements, but there's something that get like crunched down to a value. It's a combination of literal values, variables, and operators. So some other variable equals some variable plus 1 times 2. That's an expression. It's a statement as well, but it's also an expression because there's some task to get like calculated. Okay? This differentiation is not critically important, but let's just be clear at this stage. Operators that's the stuff we've been using, like the arithmetic operators, plus, minus, multiplication, and divide. And for the sake of fun, let's do this activity real quick. This should be trivial now for you. I shouldn't say trivial. This should be relatively easy for you at this stage. It's not too much added complexity to what we've already been doing. Generate expressions to add 2 variables together. So I need 2 variables, I guess. A equals B equals 75, I don't know. Or I did it real quick. Because we are running out of time, I'll just explain it. First thing I did, okay, the first step was add two variables together and store it in some other variable. Okay, so I created two variables with the value A is 5, B is 75. Why? Because. And why did I call them that? Because. So step one is add A and B together and put it in C. So what is A? And what is B? So what is A plus B? 80. So where is 80 now? Come on, wake up. Where is it? That's not waking up. Come on, try again. Who here has just been to high school? I know apathy was cool in high school, right? It's not anymore. It's foolish. Let's try again. Where is 80 stored? Hey. So then what do I do? Okay, well the next step was multiply two variables together. What I just used A and B. So 5 times 75, I don't know what it is, but where did I put the result? D, great. Then what? Well, then it was divide the result of that by the result of the previous thing, so I just said D divided by C and I put it into E. I don't know what the result is, but I put it into E. Then the last thing was add a third variable to the result, so I just made another variable Z. I added E plus Z and printed out the result. So 24.6875 is apparently the answer. Great. All those calculations. We'll pick up here whenever next class is.